Right. So in last week we have gone through DevOps introduction, cloud introduction, question and answers, right? Yeah. Today we are going to discuss about servers and networks basics. Okay. So introduction to servers and networks. So this session is very important because when we start working on cloud concepts, right? So this terminology is very important here. So you can easily understand cloud concepts if you understand this basics. Okay, yeah. So servers, what is server? What is network? Right? What are the types of servers? Right? Different things are there. Yeah. Anyone newly joined today? Yeah, you joined, right? So you'll get recordings. I provide you all the previous recordings. Okay, so just after this session, you can ping me, say hi, so that I'll provide you all the recordings, previous recordings, demo recordings. Fine. Yeah, so today's agenda here is what is server, types of servers, different types of hardware, right? So server client model and best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet mask, gateway, router, firewall, failover, load balancer, right? Yeah, today, so up to here we can cover. This will take nearly 1 hour. Okay. So up to here, types of operating systems. Okay. Yeah. So up to here, it will take nearly 1 hour. Okay. Yeah. First one, what is server? What is server? Anyone having idea? What is server? What is server? So this is a world traditional server. Okay, so currently we are using cloud servers. Yeah, this is a bit older server, traditional server, rack server. Okay, yeah, so server is having high computing power, right? Yeah, now let us try to understand the definition first. Okay. A server is a computer that serves information to other computers, right? A server is a computer that serves information to other computers called clients. Can connect to a server through either a local area network or a wide area network, such as the internet, right? So every project team, every organization, they use the servers because of yeah, developers always connect the servers, right? So developers directly develop the code on servers, right? Yeah, this is a traditional server. Server is having high computing power, like CPU, high CPU, high memory, high storage, right? So these are the drives. These are the storage drives, right? 12 drives are available. So insert, we can insert here the drives, and these are the high capacity drives like 2 TB, 3 TB, 1 TB drives, right? So server, yeah, server can serve information to other computers called clients. What is client? Client is nothing but laptop or desktops. Laptops or desktops, right? So normally in real-time projects, we can use laptops to connect our servers, right? Yeah, so we can directly connect to servers. We can work on servers. Fine. Yeah. So when we connect our server, when we send request to the server, server will give response. Fine. So every developer, every tester, they directly connect to the servers. They work on the servers. Right. So next one, types of servers. These are the different types of servers. First one is blade server, rack server, tower server. Right. So what is blade server? What is rack server? What is tower server? We'll try to understand. First one, blade server. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. So blade server is a modular, small module. See here. So this is one of the container. This is one container. Instead of this container, we have blade server, thin servers. These are modular servers, module servers, right? So very lightweight, very compact model servers, right? Yeah. So these servers are physically thin, typically only have CPU, memory, integrated network controllers, right? And sometimes storage drive inbuilt. Okay. So without storage, this server is designed. But without storage, how can we store the operating system? How can we store the applications? How can we store the data here? Anyone having idea? So without storage, can we store any data? No, right? Yeah. So these are the thin servers. So without storage, sometimes you can, yeah, sometimes storage inbuilt. Okay. Yeah. So these are the enterprise level servers. These are the enterprise level servers. So like enterprise level organizations, they use the blade servers. Compared to other servers, these are bit costlier, right? These are bit costlier, high performance servers. So memory, 48 GB memory, CPU, quad core CPU, right? Yeah, integrated network controllers, right? Yeah, but here storage, we can attach external storage to the blade servers. We can attach external storage to the blade servers. Okay. Blade servers are often seen in large data centers like Google data center, right? Yeah, UHG, Verizon, right? So different companies like enterprise level organizations, telecom domain, insurance domain companies, they use blade servers. So currently we are using cloud data centers, but earlier we used to use physical data centers, local server rooms. By the time we used to use this, okay. Yeah. Even cloud data centers, they are using currently blade servers. Okay. Yeah. Next one, rack server. What is rack server? Rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing. These are the rack servers, right? So we have one rack here. Rack is nothing but it is a big container. Inside of the rack, we can insert nearly 48 servers inside of the rack. 48 servers. Based on the rack capacity, we can insert the servers and we can connect power, we can connect network, right? We can install operating system, applications, patches, right? So after that, you can move to production server, production environment. Right. So most of the organizations, they are using rack servers. Okay. So most of the organizations, these are the, yeah. So these servers are typically general purpose servers that supports broad range of applications. Okay. So this is a towered server. This is Bitwarden server. Third one is towered server, right? Bitwarden server. A tower server is a computer that is built an upright cabinet, right? So this is only one cabinet, one server. This is Bitwarden server, right? That's standalone and that is designed to function as a server, right? So this is Bitwarden server. These are the three different types of servers normally we use in data centers, right? Yeah. So now, client server model. This is server. These are the clients like desktops or laptops you can use to connect our server, right? So when we send request to the server, we get response from the server, right? So through either local area network or a wide area network or Wi-Fi, we can connect our servers through network, right? Yeah. This is another client server model. We can connect through internet, so we can use desktops, laptops, even tabs also we can use to connect our servers. Okay. Yeah. Next one, server architecture. So let's try to let us try to understand server architecture. So different servers, combination of servers, we can prepare the architecture, right? Yeah. What is server architecture? Server architecture is the foundational layout or model of server based on which a server is created and are deployed. It define how a server is designed. Okay. Yeah. I give you example here, few examples so that you'll understand. Okay, so before going to cloud, before going to DevOps tools, first we need to understand these basics. If you understand these basics, you can easily cope up, right? While working on cloud environments, while working on cloud infrastructure, you can easily understand. Okay, server picture. So here, initial stage of implementation. So you can say first phase of implementation. Yeah, so in 90s and early 2000, in 1990s and early 2000, 1990s and early 2000. So how the servers, how the project teams used to use the servers, okay, how they used to design the server architecture, we'll try to understand, okay. Initial phase of implementation, first phase of implementation. So how the project teams used to implement the server architecture, we'll try to understand. This is very, very important, okay. Yeah, for example, I have four applications. I have four applications like Java, Git, Maven, and Tomcat. So these are the four applications I have. For example, I'm saying, okay. So by the time there is no Git, there is no Maven, right? Yeah. So how they used to configure the server infrastructure, server architecture, server infrastructure, like servers, what are the types of servers they used to use and how they used to build infrastructure, we'll try to understand, okay. Yeah, so four applications are there here, four different applications. So in 1990s and early 2000, so every project team they used to take a server, single server, one server for one application. So by the time every project team they used to take one server for one application. These are the four servers, okay. Yeah, because four applications are there, right? So for each server they used to deploy one application, right? So by the time in 1990s and early 2000, highest capacity of the hard drive is 1 GB. Hard disk size, hard disk means storage drive, highest capacity 1 GB. These are all 1 GB storage servers, right? Yeah. So by the time they used to deploy application on a, yeah, for example, four applications, they used to deploy four applications on four servers, okay? Yeah. For example, this is a Java server, Java deployed on this server, okay? So normally Java will take nearly 800 MB to 1 GB nearly currently, right? So by the time, very less size, like for example, 300 MB, the server take 300 MB of the size, okay? Yeah. So remaining space will be wasted, right? One server, one application they used to design, they used to deploy. But here Java occupied 300 MB, 1 GB means 1000 MB, right? 1000 MB, right? Remaining space will be, remaining space is wasted right here. Yeah. So here 700 MB is wasted, right? So next one, Git. For example, Git 350 MB it will take. Okay. So remaining space will be wasted, right? Next one, Maven. Maven is a DevOps tool, right? Git and Maven DevOps tools. Maven occupied, for example, 400 MB. Remaining 600 MB will be wasted, right? Yeah. The same way, Tomcat. Tomcat is web server. So like this, every project team they used to configure the servers in 90s and early 2000, right? By the time in 90s and 1990s and early 2000, hardware costing, so it was very high, very too much cost by the time, right? So even though if you, yeah, I bought one desktop by the time in 2000, 2000 I think 2000. I bought one desktop. So by the time desktop costing around 80,000, 80 to 90,000 something. Very lowest configuration. very lowest configuration by the time nearly 80,000 to 90,000. So server costing, it's a too much cost, right? So by the time, yeah, so here server utilization is very less and the server costing is very higher. It was very higher. Okay. So server costing, hardware cost, it was very higher and utilization very less, right? So that is why project teams, they used to spend more billing for the hardware, right? So this is failed concept because less utilization, more costing, right? So this is a failed concept. Okay, in 1990, yeah, in 1990 and early 2000, this concept was failed. Okay, slowly what happened, slowly what happened in second phase of implementation, what happened here, yeah, project teams used to take one high-end server, one top-end server, and they used to deploy all the packages in the same server. Project teams used to take one high-end server like this. Yeah, they used to deploy all the packages in the server and they used to configure as a server. Okay, yeah, see here, here we have four applications are there like Java, Git, Maven, and Tomcat. They used to take one high-end server, one top-end server. They used to deploy all the packages in the same server, right? Yeah, this is second model, right? After 2000. So here, what will happen? Java developer may access Java developer access Java application, Git user access Git application, Maven user access Maven application, Tomcat user access Tomcat application, right? Yeah. So every user, four users, they log into the same server, they access their respective applications, right? So here, what will happen? Yeah. So they are logging into same server. Four people are logging into same server. Here, what will happen? So Java user may access Git application also. There may be chances to access. Git user may access Maven application. Maven user may access Tomcat application. So there may be chances to access other applications also because the four people are logging into same server, right? For example, four people are staying in one flat. Two guys are staying in one bedroom. Two guys are staying in other bedroom, right? So the four people can access commonly access kitchen and dining, right? So the same way, four people are logging into same server, there may be chances to access other applications also, right? Security will be there. Yeah, security is there. Security can be implemented, but there may be chances to access other applications, right? Yeah, this is one drawback, right? So four people are logging into same server, so they can access their respective application, but there may be chances to access other applications also. Java user may access Git application, right? Git user may access Maven, like that, right? So that is one drawback. And also, if the server is crash, if the server is crash, what will happen? So all the applications will be gone, right? This is one more another drawback. This is another drawback, right? So these are the drawbacks. So that is why this is also failed concept. Second one also failed concept, right? And next one, yeah. So after few years, what happened? In third phase of implementation, what happened here? Yeah, Virtual servers came, right? What is virtual servers? What is virtual server? Started using virtual
With
servers. Yeah. So virtual server is a imaginary server, not physical server, right? So yeah, what is virtual server? What we can do in this, we'll try to understand now. So in a virtual environment, what we will do, we take one high-end capacity server here. So this we can say base operating system, base OS, right? So this is physical server. Normally we take physical server, high-end capacity server. So in this server, like RAM, RAM 24 GB or 32 GB, CPU, CPU also 32 core, and hard drive 10 TB, like this. High-end capacity server, right? So top-end server we can take. So on top of this, what we will do, we can deploy one package, which is, which you can say VMware or hypervisor, Hyper-V or Citrix. So these are the applications, these are the packages we can install. So this package will allow you to create virtual servers. So we can take one physical server, high-end capacity server. On top of that, we can deploy this package. So this package will allow you to create virtual servers, right? Yeah, so we can create virtual servers like this. Yeah. So these are all virtual servers. So 5 into 5, 25 servers. Yeah. Based on your hardware capacity, based on your physical server hardware capacity, we can create virtual servers. So these servers, these are the 25 servers, right? 5 into 5. So in these servers, we can deploy different operating environments, different operating systems here. Okay, like Windows 2016. So here we can deploy RHCL, Red Hat Enterprise Linux. Here we can deploy SUSE Linux. Here we can deploy Ubuntu. These are all Linux flavors. These are all Linux flavors. Here we can deploy Windows 2022, like this. So whatever operating systems you want to install, you can install on this 25 servers, right? Yeah. So these servers will take the resource from hardware resource from physical servers, physical server, right? So these virtual servers utilize the hardware from physical server. Fine. Yeah. So we can deploy different applications. Yeah. These servers can work individually, right? Yeah. So we can deploy operating system and applications, patches, whatever. So these servers will work as a individual servers, right? Yeah. So here, fine, it is fine. Currently also we are using these servers, but here also some drawbacks are there. Here also we have drawbacks. So when you want to deploy operating system, we use ISO image. So normally in our laptop or desktop. So if you want to install operating system, what we will do? We can take one pen drive. So in that pen drive, we can copy image, right? So that pen drive can boot as a bootable drive. So after that, we can install the operating system, Windows or Linux or whatever, right? So the same way, server side also, we use ISO image. What is ISO image? Anyone? Anyone having idea? What is ISO image? ISO is a international standardization organization, right? It is a master copy, right? So this is a primary, this is a full package of the image, full package of the image. So normally ISO image size would be 1 GB to, not 1 GB, minimum 6 GB is there currently. 6 GB to 18 GB. So only operating system image size, only operating system image size 6 GB to 18 GB, right? So here, for example, yeah, let us say, for example, we can say 10 GB only for ISO image size, for example. So 10 into 10 GB into, we have 25 servers, right? So equal to how much it would be? 250 GB, right? So 250 GB we need to spend for only operating system, only operating system. So for example, in my laptop, I installed operating system, right, which is Windows, right? For Windows, I need to spend some space, right? Same way, server side also. Here we have 25 servers are there. So minimum, yeah, each server take 10 GB for example. Okay, 10 into 25. So 250 GB we need to spend for only operating system. So on top of that, again we need to install applications, patches, graphics, drivers, right? Whatever, right? That will take more space, right? So here storage is utilizing more, right? That is one of the drawback. And also when you reboot server, what is reboot? Reboot or restart, both are same. So when you reboot the server, it takes minimum 4 minutes to 8 minutes. So normally server will not reboot immediately, right? If you restart laptop, it will restart immediately, but server will not reboot immediately. So it will check memory, CPU updates, everything it will check when you reboot server, right? So normally, yeah, client will not wait for this much of time. So 4 to 8 minutes is client will not accept. Okay. So for example, so we have Flipkart server. So if you restart Flipkart server, it takes 8 minutes to restart. What will happen? Business will be impacted. So Flipkart server we can access, yeah, people can access from anywhere, right? So globally accessible server. So that is why, so client will not accept for 4 to 8 minutes, right? So reboot time 4 to 8 minutes, and also deployment deployment time and downtime. Deployment time and downtime is higher, very higher, right? So when you deploy any applications, it will take some time, right? So when you down the server, when you restart server, it takes some time, right? So deployment and downtime is higher in physical or virtual server, right? So these are the drawbacks are available in virtual servers. Still we are using these servers, but these are the drawbacks. Fine. Yeah. So this is third phase of implementation. Still we are using, but people are migrating to, project teams are migrating to cloud. So why they are migrating to cloud, we'll try to understand. Okay. Yeah. Next one. This is also, yeah, this is also a bit costlier. This is also still we are using, but it is also failed concept. Still we are using. Okay. And the fourth phase of implementation. Fourth phase of implementation. So here we are using we are using cloud server with container with Docker containers, Docker container infrastructure. So in fourth phase of implementation, we are using so cloud servers with Docker containers, right? Yeah. So how it would be, how we are configuring currently. So how we are using this, we'll try to understand. So we can take one server, which is a cloud server. We can say this is cloud server. Like we can say AWS server or Azure server or GCP, Google Cloud Server. AWS server or Azure server or Google Cloud Server. Okay, yeah. So on top of this, what we will do, we can deploy one package same as virtual environment, we can deploy one package, which is, we can say, Docker image. So this Docker image will allow you to create Docker containers. Here we can create Docker containers. Yeah, like this we can create Docker containers. Okay. Yeah. So these Docker containers are lightweight, very thin, standalone, right? So these containers we can move anywhere, we can use anywhere. So Docker containers are advanced virtual servers. Docker containers are advanced virtual servers, right? So currently most of the project teams, they are using Docker containers with the cloud environment. Okay. Yeah. So what is the difference here? What is the major difference here, right? So here we are using virtual servers. Here we are using containers, right? Yeah. What is the difference? We'll try to understand. Here we can deploy different operating environments here. Different operating environment like Windows 2019 something. Okay. Here we can deploy CentOS like Linux CentOS. You can deploy RHGL. Here you can deploy Ubuntu. Here you can deploy Linux like this. Okay. Yeah. So different operating systems you can install on the Docker containers, right? So when we create any container, when we configure any container, when we create any container, so the container the container will have only bin and lib files, binary and library files. So when we create any container, when we run any container, only binary library files will be created in the container. So what is bin and lib? So these are the system container required files, right? So container configuration files. So this container size will be, when we create container, this container size would be 200 MB only. So when we create a container, when we run the container size would be 200 MB only. So when we deploy packages and when we deploy any plugins, patches, so after that, once you install all the applications, everything, so it would be 650 MB only, maximum size, 650 MB. So this is a lightweight environment, right? This is a lightweight, standalone, thin layer, thin server, thin containers. We should not call it a server. This is a container, thin containers. Okay. Yeah. So when you restart container, restart or reboot container, it takes 15 seconds only to restart. When you restart container, it takes only 15 seconds. Okay. Yeah. Within 15 seconds, this will be restarted. Container will be restarted. So normally, when we restart an application or any server, so that should not be down more than 1 minute. Okay. If the application or server is down for down more than 1 minute, what will happen? Business escalations will be happened, right? So that is why, yeah. So currently, these are the advanced features are there in the containers. That is why most of the project teams, they are migrating to cloud environment with Docker containers, right? So currently we are using digital sites, right? Digital sites like Flipkart, Amazon shopping site, right? So this Flipkart, for example, this is a Flipkart site, right? So here we have, these are all microservices, different microservices. These are all microservices, right? See here, these are all microservices. Each microservice we host in each container. We can host one microservice in one container, right? So these microservices will work individual. Normally, If any one application is down, one service is down. For example, I'm using Windows. So this is my task manager in my laptop task manager. So here, if I go to services here, okay, just a minute, services, yeah, services, my Windows operating system services. These are all services. Okay. So starts with W. These are all Windows services. If any one service is down, my operating system will not work properly. Okay. So starts with the W. These are all Windows services. If any one service is down, my Windows will not work properly. Right. Yeah. So because dependency on services, right? But whereas containers, these are all microservices hosted on containers. If any one service is down, application will not be down anywhere. One service is down, application will not be down. These are all different microservices available, right? Yeah. And also currently, so we are using online shopping, right? We are using online shopping, right? So from 2020, online shopping is, currently it is, before 2020. So when we book any product, they used to take like 10 days, 15 days like that. But now what is happening? 2 days, 1 days. Even if you book any groceries, within 10 minutes they are delivering. Because back end there are containers, Docker containers. So when we place the order, when we place the request, right? So immediately that is processing. Because back end there are Docker and Kubernetes containers, right? Yeah. So these are all advanced concepts, right? So currently we are using so many digital sites like Flipkart, Amazon shopping site, Myntra, Meesho, right? Jepto, Dunjo, Blinkit, different digital sites. These are all, why these are all very popular? Because of backend there are Docker containers. When we send request, the request immediately that would be processed, right? So currently we are using in lockdown time in 2020. So everyone used the online only, right? Fine. So because of Docker containers, Kubernetes backend they configured, right? Yeah. Fine. See here, these are the two different environments, right? So this is virtual environment. This is a cloud with Docker containers. So this is advanced one. Currently, most of the project teams they're using cloud servers with Docker containers, right? So here deployment time and downtime is very less. Deployment time and downtime is very less, right? So when you deploy applications on container, it takes a very few seconds, right? When you down container, when you restart container, it takes 15 seconds only, right? Yeah, without any downtime, we can use the containers. So client always look for the cost saving, right, and time saving, right? These two are very very important, right? So every client they look for the costing, right? They want to reduce the costing and they want to reduce the time also, right? So currently we are using Agile methodology. Agile methodology. What is Agile? Anyone? What is Agile? Anyone having idea? Agile methodology.
As soon as getting a requirement, we have to finish, without time period.
Right. So agile methodology is nothing but we can say parallel development. Parallel development.
Mhm.
So every project team they are using agile methodology currently, right? So one, for example, we have one application development. The application will be divided into bits and pieces. That bits and pieces we can call it as sprint. Sprint is nothing but a timeline, right? So sprint can be 1 week to 1 month. Within that time frame, we have to complete the sprints. Like developers, they need to complete the sprints, right? Yeah. So currently in cloud environment, by using cloud environment with the Docker and Kubernetes infrastructure, We are working on Agile methodology. This is very trendy. Currently, we are using advanced technology, right? So while working on Docker and cloud environments, we'll go deep dive, right? So this is just introduction. Okay, first, yeah, we need to understand this terminology and these basics, right? Yeah, so while working on Docker, we'll go deep dive. So what is Docker container? What is Docker, right? So what is cloud environment? How can we create cloud servers? How can we work on cloud infrastructure? It's very easier to handle cloud infrastructure, right? So by single click, we can create a number of servers within 1 minute, right? So while working on AWS services, we'll go deep dive. Fine. So here, so if you use the virtual environment, it is bit costlier also. But when we use containers, less costing compared to virtual environment, right? So 1/3 cost will be saved here. When we use the cloud servers with the Docker environments, 1/3 costing will be saved, and the time also less. Within 15 seconds, we can restart servers. We can deploy the packages, right? Yeah. So time saving, cost saving. That is why. So most of the project teams they're using cloud environments and Docker Kubernetes infrastructure. Fine. Yeah. For practice, it is free. Yeah. For practice, but our nation's licensing. Okay. Now, any questions up to here, anyone? Before going to next slide, anyone having any questions?
Maybe you use third phase.
Sorry, where we use?
Third phase.
This is third phase of implementation. So currently, still we are using this. Still we are using virtual servers.
What?
No. Yeah. For example, this is first phase implementation, right? First phase of implementation, second phase. So in 90s and early 2000, we started using like this. Slowly, they implemented latest environments, right? So here, this is third phase. So after 2005, we used to use virtual servers. 2004, it was started. 2005, 2000, not 2004, 2005, 2006, started using virtual servers. So still we are using virtual servers. Still we are using, but project teams are migrating to cloud and Docker environments slowly, right? So already 30% project teams already migrated to cloud and Docker environments. So whoever using virtual environment, now they are migrating to cloud and Docker environments. Fine. Yeah. So this is server architecture. We'll go deep dive while working on AWS. Okay. Yeah. Next one. What is operating system? What is operating system? Anyone having idea? What is operating system? Operating system. Yeah. So we are using Windows, right? In my laptop, I'm using Windows, right? So here, for example, my operating system, I want to show you my operating system. If I right click on this PC, if I go to properties, so here I'm using Windows, yeah, Windows 11 Home Single Language Edition, right? Yeah, so this is my operating system, Windows 11 I'm using. So Windows 10, Windows 8 we used to use, right? Yeah, so different operating systems like Linux, Windows Server operating system, Windows 2016, 2019, 2022, right? So CentOS in Linux, RxL in Linux, right? Even Mac OS also there, Solaris also there. Different operating systems are there. So operating system is an interface. It is an interface, right? Yeah. So here hardware, our computer hardware always understand binary language. Binaries. What are the binaries? What is binary? Zeros and ones, right? So 000 001 100 111 like that. So our computer means a server or laptop or desktop. Hardware always understand binary language, but human will not understand binary language. That is why we require one translator, right? The translator is nothing but operating system. So this operating system will convert hardware language to human readable language, binary language to human readable language, and vice versa for effective communication, right? Yeah, see here, this is the definition. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? See here. So between, yeah, can you mute any questions, anyone? If you have any questions, you can unmute and you can ask, or else you can mute. Fine. Yeah, so operating system is a mediator between hardware and end user, right? Next one, types of operating systems. What are the types available? See here, single user, single tasking operating system. Single user, single tasking operating system. So in this type of operating system, one user can log into the system, he can perform one task at a time, which is nothing but, like example, MS-DOS. In MS-DOS, Microsoft Data Operating System, only one user can log into the system, he can operate only one task, right? This is a single user, single tasking operating system. Next one, single user multitasking operating system. So in this type of operating system, multiple users can log into the system. Sorry, single user can log into the system and he can perform multiple tasks at a time. One user can log into the system, he can perform multiple tasks. So for example, Windows. In Windows, as a user, what we can do? We can log into the laptop, we can operate multiple tasks at a time, right? So while browsing internet, we can run background audios, right? While working on any activity, we can run background audios, right? Next one, multi-user multitasking operating system. So in this type of operating system, multiple users can log into the system, they can perform multiple tasks at a time, which is nothing but Linux and Unix. So currently most of the project teams server side they are using Linux only, right? So because Linux is having more features, more security, multiple users they can log into the system, they can perform multiple activities. For example, while deploying the code in real-time projects, in Agile methodology, while deploying the application, so developers log into the servers, testers log into the servers, even DevOps engineers also log into the servers, right, to perform the activities. So multi-user, multitasking operating system is a Linux operating system. So server side we always use Linux. Desktop side we use desktops or laptops we use Windows, right? So these are the things available. Yeah, this networks will start tomorrow. Networking is very important. Okay, so types of networks, where which type of networks we are using, right? What are the features available, what is IP address, what is subnet mask, what is gateway, what is failover, what is firewall, we'll discuss tomorrow, right? This will take 1 hour nearly. Yeah, so this is fourth session, right? This is our fourth session. So already WhatsApp group created, already people added into WhatsApp group, right? Whoever not clear the fee, you can make it by today itself. Okay. So tomorrow onwards, link will be changed. Meeting link will be changed, right? Yeah. So if you are interested, you can make the fee by today, and you can send me the screenshot so that I'll add into WhatsApp group, right? From tomorrow onwards, you need to use the new meeting link, which I share with you today. Okay. Fine. Any questions, anyone up to here? So I provide you previous recordings. So if you have, yeah. If you need that recordings, just ping me the WhatsApp. I gave already my number, my personal number, right? So I give you one more time. So my mobile number is 96422 11711 is my number. You can take down this number. If anyone newly joined today, can you provide your WhatsApp number and email address in the chat? WhatsApp number, email address, so that we'll provide you demo recordings. Anyone joined newly today, you can provide your WhatsApp number. Yeah, WhatsApp number and email address. Fine. So we can wind up here. Yeah. So tomorrow we'll work on networks. These basics are very, very important, right? So when we enter into the cloud, we need to understand cloud infrastructure, right? So before entering to cloud, first we need to understand basics. Fine. Yeah. So we can stop here. Thank you all.